So let's do a quick refresher on how to write formulas and how to name for ionic, okay? So first, let's talk about what it means if you're ionic, okay? If you're ionic, that means you're transferring electrons. You could be a metal attached to a non-metal. You could also be attached to a polyatomic. You could also be specifically NH4, because he's the only polyatomic that has a positive charge, attached to a polyatomic, or NH4 attached to a non-metal, okay? The big thing when we're writing formulas, so remember, we're not even focused on this side. Don't even look at this side, okay? The big thing when we're writing formulas is your charges have to be equal to 0, okay? Remember, this sheet is on Schoology, so you can go back and reference it. You have your periodic
Miss
table.
Payne,
Yes,
really quick, ionic transfers, right? That's what you said.
correct. Ionic
Okay.
transfers electrons. Transfers electrons. Whew. All right. Just get my spelling back. All right. Transfer electrons. And then you're gonna do your charges. Remember, you have your charges here. So like group 1 is +1, group 2, and then all your charges here. Okay. And then we learned before break that these charges down here change. Okay, and these are the ones where you get the Roman numerals. Okay, and we'll go over that again. Okay, Roman numerals. All right. So big thing is if we're writing formulas, the big thing is if it word ends in IDE, except for hydroxide, cyanide, and there's another one, peroxide. If it's one of those that ends in IDE, remember it came from this part of the periodic table. If it ends in ate or ite, then it came from this part over here, right here, okay? Remember, these are all your polyatomics. So you got acetate, bromate, chlorate, sulfate, nitrate, perbromate, perchlorate, sulfate, silicate, phosphate, or they end in ite, hypochlorite, sulfite, phosphite, chloride. Okay, the only ones you have that don't end in ite are cyanide, peroxide, and hydroxide. Okay, and I don't use those too often. If I use any of them, it'll probably be hydroxide. Okay, occasionally you might see cyanide. All right, so
what is cyanide?
Cyanide was what they used to use in rat poisoning. So you look at those old movies and they'd be like, they put rat poisoning in their soup. It was with cyanide, and cyanide is deathly for us to digest. Okay. All right, so now let's go back to this chart. All right, and let's kind of quickly review and get some practice. All right, I'm gonna clear everything. All right. So let's talk about how to write formulas. Remember, the big thing is, can you get the charges to cancel? Oh, what just happened? All right, we just want to get the charges to cancel. So let's look at this first one right here. Calcium nitrate. Calcium nitrate. All right, I just need a symbol and a charge for calcium. Anybody got know the symbol for calcium? That means the letters.
Ca2.
Very nice. So Joe says Ca, and then his charge is a +2. Now, nitrate 8 tells me that it's probably polyatomic. So let's go over to this other screen and find nitrate. Okay. If you have your periodic table, that just means you can flip it over. Oh, in the chat. money in the chat. Not
And no -3. I mean,
yes,
-1.
exactly, Marco. It's right here. NO3 and with a -1 charge, and that's nitrate. And let me just clarify. What that means is you have an N, there's 3 O's on it, and collectively that has a charge of -1. Okay, so that's what that means. So you don't have to do any multiplying. It's not saying -1 times the 3. It's saying, hey, you got this NO3, and together the charge for that is -1. Okay, so NO3 with a -1 charge. So I'm going to go back here and write that. So I got NO3 with a -1 charge. Okay, NO3 with -1 charge. So remember, we're trying to get our charges always to be equal to 0. Okay, so do these add up and equal to 0 right now? Yes, no, maybe so. +2 and a -1, does that equal 0?
Mm-mm.
No, it doesn't. So I can either add some more nitrates, add some more calciums, add some more both.
Add some more nitrate, like 1 more nitrate.
Exactly. So you're both right. Add another nitrate. So NO3 -1. Now that does equal 0. Fantastic. So that tells me when I get ready to write my final answer, I have a calcium and I have 2 nitrates. So I can just write NO3 and then 2 like that.
You don't have to put the parentheses.
Exactly. Joe said you got to put parentheses. This looks like N with 32 oxygens. Okay. We have to put our parentheses. So anytime, if you have more than 1 polyatomic ion, please use parentheses. So CaNO3, 2. CaNO3, 2. So that NO3 needs to go into parentheses. Excellent. Okay. Do not look at that one. Do not look at that one. All right. Now let's skip and let's do this one. We'll come back to the one with the Roman numeral. Okay. Aluminum oxide. Yes, aluminum oxide. Okay, aluminum oxide. Write your symbols, write your charges. So I know that's aluminum. And I know oxide is O. A lot of people are going to tell me that's the answer. Okay. But you need to write your charges to see if they cancel out to 0. Somebody online, anybody got the charge for aluminum?
3 positive.
Excellent, +3. And oxygen, anybody?
-2.
Excellent, -2. Those do not cancel out. When we have the ones, it's easier, but with these, you need to find at least common multiple so we can get them both to something. So we're probably gonna have to have more than 1 aluminum and more
It's 2
than 1.
aluminum and
What'd you
3.
say?
Is it 3 ALs and 3 oxide?
Okay, let's see if you're right. So Marco says 3 and 3, Marco, is that what you said?
No, 2 aluminum
Okay, 2 aluminum,
and 3 oxygen.
okay, and he said 3 oxygen. So let's see what that gets us. This -2, all these -2s is a -6, and these +3s are +6. So yes, that equals 0. Excellent. Nice job, Marco. So that means aluminum, we got 2 of those, and oxygen, 3 of those. That is your final answer. Al2O3. Excellent. Al2O3. Okay. All right, let's do these 2. We'll do this one and then we'll do this one. All right. Ammonium sulfide. Ammonium does not sound like an element that I know. Okay, does not sound like an element, but I did tell you guys to remember that one. Okay. Can anybody still write? I'm gonna get ready to erase in just a second.
Is it like NH4?
Excellent. Yes, it is. It is NH4. And if you know it's written in the front, it must have a positive charge. So let's go look and see. Okay, let's go look and
Positive
see.
one.
What is it?
Positive one.
Positive one. Excellent. Let me just show you guys where they're looking to find that. Okay. NH4 is right here. And it has a positive one charge. NH4 is right. Let me do a different color just in case you're like, I don't see where you're writing. Right here. NH4 and it has a positive one charge. NH4 with a positive one charge. Okay. All right, so let's go back to see what it said. I think it was ammonium sulfide. All right, ammonium. So the ammonium is NH4, and it had a +1 charge. Be very careful. You have sulfide, you have sulfate, and you have sulfite. Sulfate, sulfite, sulfide. Where do you think the sulfide come from? Is that a polyatomic or off the periodic table?
Off the periodic table.
Excellent. It's off the periodic table. The polyatomics end with 8 or 8. So sulfide is just an S. He is right here. And if I look right here, it looks like his charge is -2. So I'm going to write a -2 right here. All right. More ammonium, more sulfide.
More ammonium.
Very nice. Very nice. Good job, Marco. We want this to be equal to 0. So you want another sulfide or another ammonium? This is ammonium right here, and this is sulfide.
I guess no.
So you got a -2 and a +1.
Oh, I know
Very nice.
that one out.
The 4, yes. So, okay, excellent question. Remember, this 4 does not affect the charge. This 4 right here does not affect the charge. That means I have an N with 4 H's on it. And together, this has a +1 charge, okay? No multiplying or anything. That's what it's like saying, my name is this. I can't just take off a letter or anything because then it's not my name anymore, okay? So that's what it is, and it has this charge, +1, okay? So now we added another NH4. So now it is equal to 0. All right, Joe told us earlier, if we write it, if we have more than one, we need parentheses, because otherwise it looks like this, NH42S. So we need to make sure we put our parentheses, NH42S. Excellent. Okay. All right, here we go. Let's go to the newer
Do
stuff.
you put
Yes?
it around the element or do you put it around the actual number?
So NH4, you put it around whatever the polyatomic is. So NH4 is the polyatomic, so I would put it around this and then put the 2. Because if I do this, NH4, if I put it just around here and then I put the 2, it still looks like 42. It looks like 42 NHs versus, so it looks like 42 of these connected together, 42 of those versus 2 of these. I want 2 of these. So it says NH4, 2 of those, not 42 of these. Good question. Okay.
I think it's break time, right?
No, it's not. In a second. I
We
know,
still
your,
have 8
I know your
minutes.
knee is hurting, Eric, but you can't take a walk outside, okay? So, all right, so
Hey, and apologize.
I know, goodness gracious. All right.
It's
so-
okay. That's not even close to the meanest thing she said.
Oh, just a reminder, we are recording. Yes, Eric. All right, so here we go. Let's do this. It's okay. Now they know we have phony fun. All right, so let's do one of the newer things. Okay. Remember last time I told you that we had, if you fail like on this, on the periodic table, we will take a break in a second though. If you were not in like this column is always +1. This column is always +2. When we talked about aluminum is always +3. This guy is always +2. This guy's always +1. But everybody else over here, all these other metals, they can change. Like sometimes it may be +1, sometimes it may be +2. You may have some guys that are +2 or +3. You may have somebody that's all the way up to like +7. Okay. So I don't know which one they are. So the reason why we use the Roman numerals is to say, hey, this iron, this time, this iron is +2. But maybe this next time he's +3. Okay, so make sure you know your Roman numerals. Okay, but that's what tells us the charge. Okay, that tells us the charge. So,
Miss Payton,
yes,
is that the reason why they're called transition metals?
yes, exactly, because transition means change, and they can change their charge. Excellent. Yes. Fantastic. All right. So let's look at this one. This iron 2 chloride. Still not hard. Okay, it's just different. Iron 2 chloride. Okay. We need to find iron. See if you can find iron on this periodic table and tell me the symbol for it. We already know the charge because I gave it to you right here. So I just need to know what iron is.
Fe2.
It's Fe and the charge is +2. Excellent. +2. Okay. Because I gave you this 2 and the first one is always positive. Okay. And then chloride. What do you think for chloride? Not chlorate, but chloride.
Cl.
Cl. Anybody online got the charge for chloride?
-1.
Excellent, -1. So now we just got to get this equal to 0. Same thing we've been doing.
2 chlorides.
2 chlorides, FeCl2. Okay. So I just wrote the 2. If you still feel like you need to do this, FeCl, this was +2 -1. You need to write it again. That's fine. Okay. But that just comes out to FeCl2. Okay. All right. So that is how we do if we have to write a formula. All right. So now let's talk about if we want to name them. And I got one new thing for you, and then it's a break. We'll take a break. Okay. So I'm going to clear. Did anybody have any questions about any of these? Everybody understand we're trying to get it to equal to 0? Cool. Okay. So now let's talk about when we're naming them. Okay. Scrolling back up. All right. Same thing, we're only focusing on the ionic side. Okay, we're talking about how do we name them. There we go. All right, so we're not focused on, don't look at the don't look at the covalent side. We're gonna do that on Wednesday, okay? Still, if it's ionic, it's going to be a metal and a non-metal, or a metal and polyatomic, or NH4 with a non-metal or polyatomic. Okay. If it's 2 elements, regardless of whatever, you always name your first element. Then it's just a matter of, for your second, do you have just a second element, or do you have more than 2 elements? Okay. All right. So 2 elements, name your first element. We'll talk about this adding a Roman numeral. If it's not in group 1, group 2, silver, zinc, or aluminum. And then if it's 3 or more elements. So let's just do, let me scroll so you can see the practice ones we can do. There we go. All right, I know it's kind of tiny, but just give me more room to write. All right, so I can tell you that we're gonna skip, don't worry about this one or this one. And I'm gonna give you one more extra one. Let's do let's start with this one that I just wrote. All right. Name the first element, name the second element, change the ending to IDE.
MGBR.
MGBR2. Okay, MGBR2. Okay, MGBR2. Don't look at any of it.
Magnesium and
All right, I heard Michael say the Mg is magnesium. He is correct about that.
bromine?
It is bromide. Very nice. It's bromine, right? But he changed the ending, which he should have. Second element ends in IDE. Okay, so instead of bromine, it is bromide. Okay, that's it. Magnesium bromide. So let me just flash for a second and remind you of all of the endings in IDE. Okay, so if we're looking at these, I'll go back in just a second. If we're looking at these, remember you got, we just did bromide. What's this one? Not chlorine, but chloride. Not fluorine, but fluoride. Iodide. Okay. The tricky ones were like this one, not oxygen, but
Oxide.
oxide. Very nice. Oxide, nitride, phosphide, sulfide. These are really the only ones I use. You may see this one, selenide. Okay, I don't use it too often though. But those are about the only ones I use. Okay. All right. So now let's go back. The first one we already named. That one was easy. Magnesium bromide for that one. Okay, magnesium bromide. Now let's do, how about this one? Okay, how about this one? All right. C2H3O2. Let me ask you this. How many elements do you see there? How many actual, not how many elements? How many capital letters?
4.
4, okay? If you see more than 2 capital letters, okay? If you see more than 2 capital letters, that means you have a polyatomic somewhere, okay? You have a polyatomic somewhere. So that means you should be at some point looking on this table over here, okay? On this table over here with the polyatomic ions, okay? So let's see what we had. And you're still gonna name your first element, and then we're just gonna go find the polyatomic. So your first element is Ca.
Calcium.
Calcium, excellent. So that means that C2H3O2 is somewhere on this polyatomic table.
Acetate.
Excellent. Joe found it. He says right here, it's acetate. I don't have to change the ending or anything. It is acetate. Calcium, acetate. That's all I got to write. Okay. If it's a polyatomic, you just name it. You don't have to change any endings or anything. Okay. So this is calcium acetate. All right. I'll go back. This one was magnesium bromide. So if it comes off the periodic table like this one, we just change the ending to IDE. Okay. All right. This is about as tricky as I can get on this one. Now this one does have a polyatomic, but where is it?
In the front.
This one's in the front. So let's find that NH4 again.
The chart.
Yep, right there. It's ammonium. So I'm going to go back. It's ammonium. I'm going to name ammonium, and then it's a Cl behind it.
Chloride.
You guys got it. Chloride. Excellent. Ammonium chloride. All right. If you are good up to this point, excellent. We're going to learn the last thing, okay? This is the last thing I want to show you. This is the new stuff. We have not talked about this at all, okay? So make sure, if you were just kind of like, whatever, I know how to do this, This is the new stuff, so make sure you're paying attention, okay? All right. If the first element, okay, so notice like this one was magnesium and this one was calcium. Those are both in group 2. We know the charge for that. That's fine. Anytime your first element, okay, and I'm going to try to stay, let me memorize these. All right, I'm going to try to stay on this screen now. If your first element, okay, comes from somewhere in this area, okay, or the other ones you may see me use is like lead, tin, maybe antimony and bismuth, then you have to use a Roman numeral, okay? Because those are the ones where they change. You have to use a Roman numeral, okay? So here is what the problem said on the other sheet. One of them was PbCl2. One was PbCl4. One was FeBr2. I'm going to give you 2 more, or 3 more actually. CuSO4. And let's do actually all right, these are going to be the examples that we work through, okay? So if I give you a formula like this and you say, hey, it's in this funky area, it's in this pink box, okay, it's in the transition metals, or one of these kind of 4 that I've circled, then I need a Roman numeral. So this is how I would suggest you do it, okay? Find Pb and tell me what that element is, first of all. That's the first thing I want you to do. It's lead, okay? So I know this is lead. Lead's gonna have some type of Roman numeral. So I'm gonna go ahead and put some parentheses, okay? What's your last thing gonna be? Sorry, go ahead.
It keeps kicking Jamie out, she told me.
Oh, okay. Oh, I'm sorry. I didn't hear her come back in. Sorry. Thank you. All right. So remember, we're trying to name it. So I know this is lead. What's this Cl? Chloride. Excellent. All right. So now the only thing I got to do is figure out what is the Roman numeral for that. So this is what we're going to do. The same way we used to look at it and see how many we needed to add to get a count. So we're just going to do backwards. This is PbCl2. PbCl2. That means I had a Pb and I had 2 Cls. Okay. I don't know the charge for Pb, but I do know the charge for those 2 Cls. What is it? What's the charge for Cl? -1. This is a -1 and this is a -1. It still has to add up to 0.
So it's going to be a +2?
Excellent. It's going to be a +2. This has to be a +2. And that just means we need Roman numeral 1, 2. That's it. Okay. Let's try another one. Okay. Same thing here. Now I'm looking at this one, PbCl4. Okay. PbCl4. I still know it's still lead.
It's what? 4?
Yes, it is. Yep. And I know it's chloride. This time I'm just going to use these same ones actually. Okay.
Wouldn't it be IV?
Yes, it will be. Look at this. I'm going too slow for you guys. Excellent. You still got 2 more. Now you got 2 more Cls. Still got to be equal to 0. And everybody already said this one must be 4. Excellent. Yes. And the 4 is, Whitney said IV. That's the Roman numeral for 4. Okay. All right. Let's not do this one because it looks just like the other one. The only thing that's different is iron and bromide. Okay. It looks just like the very first one. Let's try to do one with a polyatomic, okay? Polyatomic. Now remember that SO4, he has 1 charge, okay? Don't do any multiplying. So let me give you why don't you guys try those 2? Try those 2. See if you can get an answer. Private chat me, okay? So you should have an element, a Roman numeral, and then the last part, okay? See if you can get those two. If you can get those two, we're doing pretty
For which ones? The CuSO4 and the Hg?
Yep, mm-hmm.
Okay.
So see if you can do, yep, these two. See if you can get answers for those and tell me what you get. Take a couple minutes. All right, let's see what we got. Everyone who sent me something got it right, okay? All right, so on these, I'm gonna do a little erasing down here, okay? All right, so we do need Roman numerals because it's not in group 1, group 2, silver, zinc, or aluminum, and I'll show you again where that is on the flow chart, just so you remember, okay? All right, so we had copper sulfate. Now I'm gonna write this again just so you can see exactly how I would do it, okay? So you had CuSO4, okay? Looks like there's just one of each of these, one copper, one SO4, okay? Because remember, now I see there's more than 2 elements, so this one must be a polyatomic. SO4, be very careful. SO4 is over here, it's sulfate. Be careful, not sulfite, which is right below it, okay? That SO4 has a -2 charge, okay? The biggest thing I saw today is people wanted to take that -2 and multiply it by 4. You do not need to do that because sulfate, SO4, has a -2 charge, okay? So that has a -2 charge. Well, all you got left is the copper, and we know they have to be equal to 0. So this copper must be +2, okay? So when I write out the full name for it, okay, full name for it, I have copper. Its charge is +2, Roman number 2. And that SO4 was sulfate. Okay, copper 2, sulfate. All right, let's try that HgNO3 Let's try that one. Okay. All right, so I'm going to write that one again. I'm going to break it out. So it says HgNO3 So I'm going to say HgNO3 because there was 2 NO3s. Okay. Again, be careful. There's a lot of them that look alike. Here's nitrite, but that's NO2. This one's NO3. This one's nitrate. Okay. It has a -1 charge. Remember, we don't write the ones necessarily, but that's what it is. It's a -1. So -1 right here, -1 right here has to be equal to 0. So this one must be +2. Okay. All right. So this is, gotta go find Hg.
Wait, so I'm confused a little.
Okay.
How do you know that, like, the first element, since it's like a transition?
Right. You have to work backwards. So I don't know. You're right. I did not know this was +2, right? But you did know that those NO3s were -1, right? Do you remember that? So
Yeah.
right. So right here, this this NO3 is -1. But remember, when I wrote this -1 here and this -1 here, I know that all of these added up have to be equal to 0. So we're going back.
So you just basically find the missing piece?
Yep. Mm-hmm.
Oh, okay.
Yep.
I was confusing myself.
It's okay. Listen, if you had a question, I bet at least 2 more people had it. They just didn't say anything. Okay. So, so because this -1 and this -1, that's essentially a -2 together, and it had to be equal to 0, then this Hg must be a +2. Okay. We're just going backwards from how we did it last time. So that Hg is right here. That's mercury.
Can we do some more examples?
Yep. And then Roman numeral had to be 2 because that's what we got right here for the charge, plus 2. And then NO3 was nitrate. Okay, all right, I'll leave those there. Let me give you some more. I'll give you like 2 more, and then we can take a break. Or we might just end early. Okay, all right, let me give you some good ones. How about, I was just looking at some earlier. All right, here's one. See if you can get this one. Let's do a different color. Whoa, what happened? There's one. And then how about all right, there's 2 more. Let's try these. Okay, I'm not giving you the answer yet, but just in case you are stuck, let me start you off on this one. I see. Okay, this is just in case you're stuck. If you got it, then that's great. This Fe2O3, okay, the first thing I would do is space that out. So I have 2 Fe's and I have 3 O's. And I know that their charges have to be equal to 0, okay? And you should know that this is something. So you have one name and then parentheses and then another name, okay? So that's just to get you started. All right, so the biggest thing is starting out, I would make sure I expand those questions out, because what's happening is I have some people getting the correct overall charge, but you have to remember that has to be, I want to know the charge for just that one ion, okay? So for instance, on this first one, we have iron. We have 2 irons, okay? So I know that's iron, so I'm just going to go ahead and write that, okay? I know this is iron. All right, and then the oxygen, what should I write behind here? What should that be?
Oxide.
Oxide, very nice. All right. I only know the charge for one of these. What do I know the charge for? Iron or oxide?
Oxide.
I know the charge for oxide. Well, yes, you figured out the charge for iron, right? But I know oxygen is always a -2. So that's a -2, -2, -2. All right. Now, here's where the people are getting mixed up. A lot of us are saying, okay, I know this has to be, I know this iron has to be a +6 for me to, so don't tell me that the answer is 6. What does each one of these irons have to be?
3.
3, excellent, okay. Each of these are 3. Some people are going, like if they're, they'll say this must be a -6, so this must be a +6, so they're telling me this is the number, but this is the number that I want in the parentheses. Yes, they add up to +6, but this is the one I want in the parentheses. So this is iron 3 oxide, iron 3 oxide, okay? All right, so now let's do that top one, okay? Again, let's space it out. I'm gonna do it up here. There are 3 nickels there. This is the one that's really throwing us, okay? There are 3 nickels. I'm gonna write out 3 nickels. And there's 1 phosphate, PO4. What's the charge for phosphate?
-3.
-3. Now, yes, for that nickel to cancel out with phosphate, it does have to be overall a +3 charge. But if I do this, +3, +3, +3, That's not 0 anymore, right? That's not 0. So let's take those back off. What do each of those nickels have to be?
1.
+1. Excellent. This is a +1. This is a +1. This is a +1. So then that one is, ooh, I'm running out of room. Nickel,
Phosphate.
1. Oops, 1. I'm sorry, what'd you say?
Oh, so you do put 1?
Yes, you do put 1. Nickel 1 phosphate. Because you're telling me, hey, this nickel has a charge of +1. There just happens to be 3 of them. So total, they are +3, but each one of them is +1. Okay. All right. So we're going to do a lot more practice on Wednesday. And you'll have like a little, our normal homework quizzes that we do in class. And then we're going to learn covalent. Okay. I will, just if you're interested, I know this is a stretch. I will put 2 worksheets, one for formula writing, one for naming, and I'll put the keys on there. Okay, so just so you can, if you want to see how you're doing. Okay, you guys did excellent today. Thank you for participating, and you guys can have a great day.